Towards a categorized complexity search engine, organizing CS-related topics. System functionality. We built a Chrome extension that analyzes search results in Google. The extension assigns each result to one of three categories, and it displays a category indicator next to each link. We have three categories: non-CS, CS Basic, and CS Advanced. We got training data and test data from each of these categories from the following sites listed on the slide.
So this project is really useful because it helps you to focus on on what you're looking for when doing a search. It lets you filter things that are not related to CS by just looking at the category. So if you're looking to learn something new in CS, you can just ignore them. You can also focus on basic concepts or advanced concepts depending on your needs. If you're looking for a tutorial, you can just look for basic stuff, but if you're looking to do research on a new topic, you probably want advanced ones.
Existing projects. So just recently, about a couple months ago, a third-party developer came out with Google.Categorized. What this does is basically categorize Google search results into pretty broad categories such as sports, news, and technology. This is different from our project in that it categorizes on the fly, and it doesn't categorize based on complexity of the document. Rather, it just categorizes into broad categories. Also, various research groups such as Microsoft have used SVM to cluster search results into categories. Basically, they're doing the same thing as us, except same thing as Google Categorized. Some development tools that we're using that helped us were scikit-learn, a machine learning toolkit in Python, PDF Miner, and PyQuery, two text extraction libraries, Request and for HTTP request, Tornado, an asynchronous web server, stemming.porter2 for stemming, and jQuery to insert elements into the DOM and to adjust the UI.
So the way it works is a user makes a search request to Google, Google comes back with the search results, and our Chrome extension takes the results and sends it to our server. The server categorizes them, sends the categories back, and then the Chrome extension shows the category and the UI. We decided to learn a learner, and after a long research, we figured out to learn a 1 versus all epoch online perceptron. 1 versus all, it means it will make one test per time, so it will first test if it is non-CS or not. After that, it will test if it is basic or not, and based on that, it will either decide between basic or advanced. Then we use epoch because epoch reduces overfitting errors, and then we use it online because it allows continuous feedback. So to choose between the learners, our options, we decided to make it our vector space, and the options were bag of words, TF or TF-IDF, or hashing for our vector space itself. Then the learners were k-nearest neighbors, multinomial naive Bayes, passive-aggressive perceptron, SVM, and SVM all versus all. This gives us 28 different learners. We evaluate them all against our testing dataset, and the results were that multinomial naive Bayes, perceptron 1 versus all, and standard gradient descent are overall the ones with best accuracy. However, if you look at accuracy per category, the best ones are only perceptron 1 versus all and standard gradient descent. By looking at these results, we choose the ones with better accuracies, and we test them against real search queries of decision tree, radix sort, Obama, and SVM document classification. From these results, we choose a perceptron with TF-IDF to be the best option. So most of the research have actually found that SVM is the best option, but in our case it wasn't. The reason is because our dataset was not exactly the best for SVM. It was completely unbalanced, which means that it was not good for actually figuring out an easy bias system. SVM will try to bias against the biggest dataset, which in this case is WAD. Also, the dataset was too small to actually use kernels, so we were bound to only use linear kernels, which makes it as good as a normal perceptron epoch. So we decided to go with an epoch perceptron for Occam's razor. And also it's an offline learner, which means we lose the option of feedback. Therefore, perceptron is a better option.
So here's a demo of our project. So users type in their query in the top bar, and it categorizes all the search results with one of the three colors. As you can see, this decision tree Wikipedia article was categorized as a beginning article because it just basically gives examples of decision trees, and it's good for learning. This decision tree page was classified as an advanced topic because there are lots of mathematical formulas, and it gives more details on implementation and research. And as you can see, all the rest of the search results were classified as one of the 3 categories. Here we see the categorizations for radix sort. It's a CS document, so all the categories are either categorized as basic or advanced. Most were tutorials. Here we see Obama's results. So all the search results were classified as non-CS, but one of the results, the Twitter result, was classified as a basic CS document because Obama talked about using JavaScript in one of his tweets. Here we can see SVM document classification. This produces many research papers and advanced documents, but the Stack Overflow and Quora results were classified as beginner CS documents because they give an introduction to SVM and how it classifies documents.
So, future additions we can do to the system is adding user feedback into it. Right now we have a small feedback system, but it's for testing purposes, and we should add it in the UI. We could also improve our training dataset to make it more balanced and bigger and more robust. That way our IDF system will be better, and also we will learn better models of SVM. We could also allow personalization of categories per user, so each user could learn if the category is basic or could define what's a basic or hard CS problem. And we could also take into account extra features that are not only in the text, such as the file formatting or the domain.
So after extensive testing, we found that TF-IDF Epic Online 1 vs all Perceptron had an accuracy of greater than 90%. This is the one that we used for our final project. Perceptron is better than SVM for small and balanced training sets, and user feedback allows continuous learners improvement.
Thank you.